we are only going to talk about two things. And so with sines, I need you to go ahead and focus on one thing we do with sines always in geometry. Sine is what over what? Opposite over hypotenuse. And we're going to talk about opposite today, okay? So sine, just focus in that it's going to be opposite of it, okay? So it says for the following, go ahead and solve for the triangles here. Well, as you can see, the very first one we got, they've given us two sides. And so, what do you do to find the other one? What do we do to find the missing side? There you go. Also, does anybody know anything about these numbers? How special? There you go. So this actually is just 4. So if you found the hypotenuse, squared it, subtract it from the leg, which is 3, squared that, subtract them, take the square root, you end up with 16, take the square root of that, it gives there. What about finding the next one? Bless you. It does. However, it's not a right triangle. Exactly. We don't have this symbol here. We can't assume it is because it's not marked there. So now we come to a problem that says we don't have a right triangle. So the idea of using sine or Pythagorean theorem will not work here because those only go for right triangles. So now the idea is, okay, so what do we do in order to find this one here? And this is where we use our law of sine. Law of sine basically sets up a ratio, as you can see here. And if you notice from the diagram, the sine of one angle over its side length. All right, I'll let everybody get set up. We have like 3 or 4 people still. You can go. Go ahead.
Do you have a phone charger?
I do. Let me do these notes. All right, so then, as you notice, the sine of this angle divided by the side that's corresponding to it, as you can tell, they both have the same letters, is equal to the sine of this angle over its side, which is also equal to the sine of that angle divided by its side. So yes, you see 2 equal signs, you're like, what type of equation is that? Well, the deal is those could be used, you only have to use 2 out of 3. You don't have to use all of them. It's just saying all the ratios of the sine of the angle over its side is equal to all the rest of the 3 sides itself. So if we're looking at a problem, and let's say you're given sine A and B, well, you can go ahead and get rid of C if you need to. You only use 2 that you need. You will not be using all 3 of them at once. Okay? So let's see what that looks like in an example. I want to look at an example, but all right, we got to talk about one thing first before we do this. Okay, for sine, you're going to have to see there are 3 different outcomes you can have for sine. You can have it where there are 0, 1, or even 2 triangles that work with those measurements. Okay? So when you're looking at these type of deals, so you remember our angle, angle, side, angle that was talked about in geometry. Well, the idea is they give you this angle, then they give you this angle, and let's say they give you that side. Well, if you notice, guys, what they've given you is, this is what we don't know. Well, the deal now is you can set up and say the sine of A over its side is equal to the sine of B over its side. And that's how you'd set it up. And from there you have numbers. You'll have numbers where the black writing is, and then B will be the one thing you save for. You'll solve for. And so when you have 2 fractions, what do you do in order to solve for 2 fractions when something's unknown? Exactly, cross multiply. Angle, side, angle, well, that's going to look like this. Angle, whoops, that should be capital. Side, and then we have angle. Well, what you notice in this scenario, guys, is that we're given two angles. Well, how do you find a third angle of a triangle? How would I find that angle there? Say this is 30 and this is 50. How do we find the third angle? They should all add up to equal what? 180. So 30, 50 gives you 80. What's going to be that missing side, that missing angle? So you use that in order to do it. So angle, side, angle. You'll use that for that scenario there. And of course, the last one's going to be side, side, angle. And so we'll go ahead and talk about that. And if I can find it, there should be one here.
Section 1, and the title of the section is Law of Sines, sorry, not cosine. No, they haven't. Okay. Alright, before we get started, I need to make sure that you know
You don't need to write anything down right now. All I need you to do is just watch.
triangle is.
There's nothing you need to write down here.
Good, there's no right angle. An oblique triangle means that it doesn't have a right angle as one of the angles. In other words, it's a triangle that is just not right.
So he's talking about triangles right now that we just discussed. So it doesn't have a right triangle in it, so it's oblique. So every angle is going to be something else besides that.
Okay? Alright. So an oblique triangle is a triangle that does not have a right angle. So far in this class, we've learned trigonometry with right triangles, right? The problem that we were dealing with last class is the triangle did not have a right angle. You had to create your own, right? So I am going to show you how you can work around that. Okay? We're going to work around not having a right angle by using the law of sines. Alright. I need you to draw a triangle that's oblique.
So 102.3, and then angle B is 28.7. And so from here, well, we could figure out the other missing angle, right? Because what we need to find is, well, here we go. What situations this triangle represents? It is, oops, angle, side. Do you need to check for ambiguous case? No, because it's not side, angle. So we look at this, we say, okay, let's go ahead and figure out angle A real quick. So angle A is 180 minus one angle minus 102.3. And somebody with a calculator can tell me what that is? 49? Even? Perfect. All right, 49 even. So there you go. Angle A. We found that one. All we have is two things left to find and we're done. So we go on and say, okay, now we need to figure out what side. It usually says go ahead and find the smallest side first. So we'll go ahead and find that corresponding here. Okay? Oh, what did they give us? They already gave us B, didn't they? 27.4, is that right? Yeah. So we know that. Let's go ahead and find side C. So C is going to be equal to that ratio. And so we set it up this way. And I shouldn't put an equal sign. I'll put an arrow to say this is the work you need to do. Have they given us an angle and its opposite side in this problem? Have they given us an angle and an opposite side yet? Yes. They've given us B and its side B, right? They've given us angle B and its side B. So I'm going to go ahead. Sine of 28.7 28.7 over length of its opposite side, which is 27.4. And you set that equal to, well, let's go ahead and look for C first. So the sine of 102.3 over, we don't know what C is. So we put C there. And now we're left with fraction equal to fraction, or ratio equal ratio. And you solve this by cross multiplying. So, you set that up here. Oops. And so as you can see, I've cross multiplied. Kind of drawing arrows to let you know where they're located. And we're solving for C. What do you think we need to do next? Divide by sine of 287, or 28.7. Making sure your calculator is in degree mode, we go ahead and do that. I recommend using alpha y equals to type it all in, but you can take your chances any way you want. And of course, if you do have it in radians and you're starting to come up with the answer, like I just did it, my calculator's in radian mode, I end up with negative 65. That doesn't make sense. So it'll give you a good hint. Sometimes it'll give you a good hint that you're in the wrong mode because you're getting an answer you shouldn't get. So we end up with length of C, and we're going to go 2 decimal places, rounding. Now, some of y'all, when you came in, you said the packets are pretty thick. I said because there's a lot of room to do work, and you can see it takes a lot of room to do these things. Because then the last thing that's left is we're almost done. We've got angle A, side C, and now we need to finish up with the last one, which is what? Side A. So I'm going to have to try to fit it in here. So
unless it specifically asks for like, if you only find one thing, we have to solve one triangle?
you always, yes, it'll even say solve for the triangle. Or solve the triangle, I think it's what it says sometimes, which just means you need to know 6 bits of information. They'll always give you 3, and you've got to find the other 3. So again, we set it up the same way we did in order that the same way we found C. What's given to us, which is here, equals something that's given to us over the unknown. And so in this case, it's side A is what we're looking for. So cross multiply there, divide by sine of 49, or divide by the sine of 287. Why do I keep saying that? Sine of 49 over. Let's see what that equals. I would recommend, since I'm coming up with these answers right now, you don't really need to, I'd recommend at some point going in your calculator, just seeing what it looks like, going through the motions of typing it in, and see if you can get the same answer as me, just so you're inputting into your calculator correctly. And now we're done. We found angle A, we found side A, and we found side C. And the good thing is, this was not an ambiguous case. So, angle, side gives us just everything we need to know just for one triangle. That only works for one triangle. So let's now see what this looks like. Another example. Number 2. So another angle side scenario again. And so angle A is 63, B is 49, and C is 78. So be careful, guys, and not just go through the way the problem's set up and say, oh, this is an angle side scenario. Because now as you look at this triangle written all out, is it angle side? It's angle side angle. Do you see that? Do you see an angle? In between the two angles is a side, and then the other angle that's given to you. So this is an angle side angle, which is good because this is not an ambiguous case. And you go through all the steps of trying to figure out what this one is. So for here, now what's weird about this one is you don't right off the bat have any angle in its corresponding side, do you? I've given angle A, but I'm not given side A. I'm given angle B, but I'm not given side B. The problem we just did, they gave us angle B and side B, which was nice because we used it as our, and I like to use the term reference ratio. That's what we used twice on the previous problem. Here, we're not given that. But can we do something to find it? What? There you go. In solving our answer, we could go ahead and find the one thing we're going to need to find the rest of them. So you're looking at what? 68? So there is your angle C. Taking 180 and subtracting it from the other two angles, and there's the other one. So now that we know that this is 68, now we can go ahead and use that information to, because knowing this now means that I can say, oh, the sine of this over that is my reference ratio. Now I can set everything else up to find the rest of the answers. So we can go through and say the sine of, let's find A first. So the sine of 68 over 78 is equal to, well, angle A is what? Over the side of A, we don't know. Cross multiply. And then we divide, right? So for this one again, 78 sine of 63 over the sine of 68. Two decimal places gives you, there's A, now we'll do the same thing for B. We use our reference angle again, guys, our reference ratio again. Mikhail, you're not getting the same thing.
Like, I don't know, it's always like 2 numbers off.
2?
Yeah.
Interesting. That's 2 numbers off.
Yeah. I got
380
like,
did be a lot.
I got like 7, and then
All right, so here's this. Sorry it's smaller. I just got to make sure I get everything to fit in here. So the good news about this type of scenario, guys, is that it's almost the same thing over and over and over again. There's really not a lot of venturing off or trying to solve problem-solving skills on this for the most part, like it was in the last unit. Last unit, you had a lot of different angles you had to go in and solve certain things. This one is pretty much, hey, this is how you find one side, this is how you find the angle. And there's that. And so you're done. You found your two sides in your angle because they gave you two angles and one side. That's what's left.
Is the link at the bottom the same videos we just
Nope.
watched?
This is a different link. This one's more straight to the deal of what it is. All right. So let's talk about ambiguous case. All right. So with ambiguous case, guys, as he said in the video, you can have three different outcomes. No triangle, one triangle, or two triangles. Okay? When no such triangle exists is whenever... Now remember, what they're showing you is you'll be given this. You will be given this side, this angle, the dark side, and the other side. You'll be given those three things. That's why it's showing you in this graphic. That's how it looks. And it can pair up in these different ways. So as you can see in number one, the side length they give you that's opposite of the angle given to you is too short. So if I'm given like a 120-degree angle, like this, and they give me a side length of 1 that corresponds to it, well notice, if that angle is large, that means the side opposite of it should be very large, right? Because in order to close in that gap, I need to have a large length side that goes there. Well, if they give me a small one like this is showing here, it will not connect, so it does not make. And what they've done here to figure that out is they said this. If this is angle A, this is, he said A here, and this is H, this is B, and therefore that's A. That's what they've given you. They've given you angle A, side B, which is next to A, and then A, side A, which is opposite of A. And the idea is this. Take this information and take this length and multiply it times the sine of that angle. So we say B sine A. When you find that, take that H and compare it to the one side you'd have, the side that's given to you. If it's less than, no triangle exists. Now, if you were to set this up normally, guys, here's what would happen. If we were to look at this, and let me go ahead and branch off real quick. Let's say I'm given this is, whoops. Let's say this is 85. This is 17, and this is 2. Okay? And let's just, for the grins of it, just go ahead and finish off drawing a triangle. So let's go through, guys, let's go through the process we just did. And those two exercises you just saw. Let's go through the process. Are we given an angle and its congruent side? Are we given an angle and its opposite side? Yes, we are. I should write that a little bit more central now. So what do I do in order to figure out? So this is A, this is A, this is B, and this is B. Okay? So let's set this up like we would. So the sine of 85 over 2 is equal to the sine of B over 17. What do we do to solve, guys? What have we been doing in the previous two problems? Cross multiply. So 17 sine of 85 equals 2 sine of B. We are trying to find B here. So you'll divide by 2. And you're left with this equation. Well, how do we figure out what angle A is? Or B. How do we figure out what angle B is? Inverse sine. So in your calculators, guys, let's do the inverse sine. So press second sine. Do alpha y equals, and put in the 17 sine 85 over 2. Do what? That's what I was hoping would happen. I want to make sure everybody does this. Everybody get in here. If you put this in your calculator and you go through the steps. Now, I'm showing this because of two reasons. One is, this is to prove that if A of B times sine of A, so someone real quick, what is 17 times the sine of 85? What's 17 times the sine of 85? 60 what? 16.93. So H is equal to 16.93. How does that compare to what A is? Would you agree that's right? In this example, because what's A equal to? This is Esmondary. Hey. He is not here today. Yep. Oh, yep. He's not here. Yep. You're welcome. So, this proves, you can go through this process, guys. If you go through this process like you did before, we've already done it twice. We did the exact same thing here, and we end up with an error. When you end up with an error, that means no triangle exists. It proves that that length of 2 is not sufficient enough with an angle of 85 degrees. It falls short, just like what the diagram shows you there on the very left side. Now, we went ahead and said, okay, let's use what this teacher was talking about, saying, hey, before writing all that stuff out, before doing any of that, what if I just go ahead and do B times sine of A and compare that to side A? And it proves that he's right on that. So this saves, and I know you guys have not really done this, so you don't know exactly what you're missing out, but if we can do this trick here, now here's the deal. This works out great to save you a lot of work. However, there is some memorizing that needs to be done. You do need to memorize that scenario. If your side A is less than, and now let's write it out this way. If A is less than B sine A, then you have no triangle. This scenario here, if A is equal to B sine A, then you have one triangle. The last one, if side A is greater than B sine A, you have two triangles. You have to memorize these. So I'm writing them down and box them for you. Because here's the deal is, when you do option 1's nice, because when you go through, set it up, and do your math, all of a sudden you have an error, you're done. It doesn't work.
I wasn't getting error when I was doing that on the first problem.
Did you do second sine?
Second sign?
Yes, because we're trying to find an angle, Duke. Anytime we're trying to find an angle, you use second and the trig function. Because I did the same thing you did. I got in a hurry and put in sine of all that stuff and end up with an answer. Matter of fact, I ended up with 0.147. But the problem was I didn't do inverse sine. I didn't do second sine. When you do second sine, you'll end up with an error. All right? So as you can see here, again, number 2, they're giving you an angle, a side and a side again. However, the side length this time equals that height that he's talking about in the problem. And of course, the last one, the angle they give you has the right measurement because, and usually the reason why, guys, is because this angle is so small. This angle is so small that when it goes out and you have the leg that corresponds to it, that leg can swing around and hit twice because it's long enough. All right? Let's dive in some examples. I think I'm painting a picture enough. We'll just go into some more examples. Let's see what that looks like here. So, they gave us side A is 15. Side B is 25. And angle A is 85 degrees. This represents, if you go around the triangle, side, side, A. All right? Need to check for ambiguous case? Yes, you do. So what I would do now, knowing the information I was just told on this video, I would take B times the sine of A and see what I get. (25) times the sine of 85. So 25 sine 85, and you get 24.90. I'm going to box that for now. It's not really an answer. It's not an answer per se, but I'm just going to use it so you guys can tell, hey, this is the thing we're going to use to compare to A. So, what is A compared to 24.9? So A is 15. And you said it's less than. Since it's less than, that tells us that there is one triangle. Since it's less than, there is one triangle. And so now we go ahead and do the work. Because 15 is less than h, the height, so we go ahead and say there's one triangle exists. And so we dive right in. Yes? I'm sorry. Oh! I'm sorry, guys. You're right. Thank you. I'm looking at the very top here. You're right. No triangle. Let's go ahead. Since you can at this point say no triangle, or we can dive in real quick and say, okay, let's do this. Let's find out what B is, because that's all we can do really. Because we're given this angle, this side. There's our reference ratio. They gave us a side here, and we need to find its angle. That's the only option we have, guys. We have no other option here. So, sine of 85 over 15 is equal to sine of B over 25. Cross multiply. Divide. And we figure out if that is exactly what we need to be getting. So second sine. Whoops.
Do you know when we'll need a second sine A? Or you just regular sine?
Whenever you're trying to find an angle, you have to do second sine. Whenever you're trying to find an angle.
But when you find a sine, you don't have to.
You do not have to, nope. And of course it confirms, right? Which means your answer would be, it says solve the triangle. Over here you'll say no triangle exists. It proves again the one thing we did up here. It's less than, once you get it right, and obviously I'm still struggling with it. Once it's less than, if A is less than height, or your A is less than B sine A, then you have 0 triangles. And that's what happened there. And so then we go ahead, move on to the next problem. So we dive in first off by labeling the triangle or drawing it, because after a while this triangles won't be drawn for you. You're going to need to do them yourself. So just be used to labeling them, see what they look like. Then I like to go in and add what's given to us. And A is 42. So let's go ahead and do exactly what we did earlier. Well, first off, this is a side angle. So yes, it's ambiguous. So A is equal to 22. H is equal to B sine of A. B is 12 sine of 42. So this one you don't use second sine because we're trying to find a length of a side. So 12 sine 42. And you get 8.03. Well, compared to A, which is equal to 22, what inequality symbol goes there? It's greater than.
You have 2?
So you have 2. Now let's see what this looks like. When you have 2, and this is the reason why there's lots of extra space, guys. So I'm going to go ahead and start at the upper right here, and we're going to start going down. Okay, this will be for triangle 1. Triangle 1. And we go through and figure out, the only thing we can figure out, guys, is what? Angle B. So I'll go ahead. Sine of 42 over 22 is equal to the sine of B over 12. Cross multiply. Divide. And to save some space, which you guys should see by now, you take the inverse sine. We're finding the angle, so it's inverse sine. So you end up with this number here. We got an answer, so we know that a triangle does exist. Whether it's 1 or 2, we don't know yet, but we did get an answer here. If we had no triangle, we would have an error here. And we move on, say no triangle exists. This one we do have an answer, so that does exist. So we're going to go ahead now, guys, and finish this off. Okay, so we come over here and say, all right, we just found out that B is equal to, and so I'm going to do it in a different color because we found this, 21.4 degrees. Well, how do we find, well, what can we do next, guys? Find C. So let's go ahead and find C. How do we find that? That's finding side C.
Yeah, you're right. Sorry.
No, you're good. What do we do?
180 minus 42.
Take 180 and subtract it from those other two sides. Obviously not drawn to scale. There's your side C. So I'm going to go back and put that. All right, only one thing left. Only thing that's left is going to be what, guys? Side C, and you're done. That one triangle. So we go through, did what we did before. Use your reference ratio, which is A's. So the sine of 42 over 22 equals the sine of the angle we just found over our last unknown. Cross multiply and divide. And you end up with the length of your last side. Okay, so there you go. 1, 2, 3, done. Triangle 1's finished. Okay? Now let's test for an ambiguous case, which we do have the opportunity. That is going to probably happen because RH is less than RA. RA is greater than H. So it's probably going to be two triangles. Okay? So let's just test it. So what we do now is this. You take the first angle we found. What's the first angle we found, guys? 21.4. So you take 180 and you subtract it from the first angle you found. This is to find the second triangle. This is going to be the angle. I'm sorry, the second B angle. So you found the first B angle to be 21.4. Now let's see if B can be another angle. So what you found was, you found the triangle where the leg was here. So you kind of have this kind of triangle here, right? That's why C is 116 degrees. So this angle right here, this is obviously not drawn to scale. Do you agree? 116 degrees would make it an obtuse triangle. So that means we found this length on angle. We found this angle here to be smaller. So now let's go ahead and see if it can be another angle. So we subtract it from 180 and we go, all right. So this ends up being what, 168.6? 58. Let's see if this works. So we pick up from here. We found the new B, so that's there. What did we do next? We took what? We took the two angles and subtracted from 180. We're going to do the exact same thing, okay? So this takes us to right, whoops, there. Now we pick up from where we stopped. So second angle C is 180 minus 158.6 minus, what's the other angle? Is it even? Is that what you get? Minus 158. What did you get, Johnny? Well, could that work? No. So guess what? The only answer you have is this here.
But did you have to do all that? Because I did it. I just took the 158.6 and I added it to the first answer that you gave us, which was 42.
You can do that. It's the exact same thing. You added this and compared it to 180. And you said it's too much. Here you can subtract both of them. I'm just trying to do the exact same steps over again. All I'm saying is, for the second triangle, guys, you don't have to do all of that. You just go ahead and say, okay, take what I found for angle here, subtract it from 180 to find its supplement angle, and then from there, you go ahead and say, oh, that doesn't work. Now, guys, in the case that it does work, because I'm going to go ahead and stop notes now. In the case that it does work, you'll end up with a new angle. And this angle right here will be there. And you do exactly what you did here to find the last side. And that's it. Yes, Aiden.
To make it easier, could you just draw another triangle?
You can, yes. You can. If you want to do that, it's fine. Sometimes there's not enough room. Just because it can get a bit lengthy. Alright. Guys, we tell you, you grab your cell phones. Hey, for your homework, listen up. When you go in to do your homework tonight, or whenever you get it done, it is going to have probably 25 problems. It is because it's the homework for the whole entire unit. I'm going to do it all in one homework assignment. That way, there's no discretions of what's due and when due, or what has to be done and what doesn't. It's all here. It'll say chapter. It'll say Unit 7 homework. And you just go through and do what you can. Stop. Do the next unit. Do what you can. Stop and go for it. And they'll be in order. They'll be in order. So as soon as you see a problem you don't know, you probably worked hard enough.
What if I lose all the way?
So I'll give you a heads up on that.
So